Okay, my little hacker army. We're going to be going over what are octal mode bits. Octal mode bits are the numbering scheme that Bash uses to assign permissions to files and directories. How does the numbering scheme work? The numbering scheme is not actually 1 through 8, it's actually 0 through 7, and each permission bit has a specific number attached to it. 0 equals no permission, 1 equals execute permission only, write equals execute permission only, 3 equals write and execute, 1, and so 3 is basically 1 plus 2, meaning that 3 is both the execute equal 1 and the write permission, or the write equal 2 permissions together. So 3 is write and execute. 4 is read permission only. 5 is read and execute, because that means 1 plus 4, meaning that it is both the execute equal 1 and the read equal 4 permissions together. 6 is write and read, so 2 plus 4, meaning that so 6 is 2 plus 4, meaning that it is both the write equal 2 and the read equal 4 permissions together. And then 7 is read, write, and execute together. Right, that is 1 plus 2 plus 4, meaning that it is all the permissions together, right? Execute being 1, write equal 2, and 4 equals 4, and then read equals 4. There we go. So in sum up, here's the little graph. Okay. 0 equals no permission, 1 equals permission, execute permission only, 2 equals write permission only, 3 equals write and execute, 4 equals read permission only, 5 equals read and execute, 6 equals read, write and read, and then 7 equals read, write, and execute. So that is what are octal mode bits, but I'm actually going to show you. And so we're going to go into terminal. And to change this using let's just hit ls minus l. Okay, so we got rwx. So let's actually change it up. Okay, so we're gonna hit chmod, and then let's give it no permissions. Right, 000 space file.txt. Boom. Okay, and we go ls minus l. And now it has no permissions. Now let's just say we're just going to be doing, say, let's just give ourselves, the user, read and write permissions, but no execute. So we would be doing the same thing, except we would just be putting, instead of 0, it would be 600. And now we just have the read write permissions, and nobody else has any permissions. That really is mostly what you're going to be using. Because if you have the execute permission turned on all the time, it can get in the way of things. And the file is going to be constantly asking you, do you want to run it as a program? Do you want to run it as a program? It's just more hassle than it's worth. So, but let's do 5. Okay, and ls, now we have read and execute. Or let's do, 3. Okay, and now we have write and execute. We can't read it, but we can write it and execute it. So, but let's go to 7, and 700, and now it's just read, write, and execute. And let's go back to 600. So there you go. Now it's back to read and write. Now, what if I want to do it with the, instead of the user permission? What about the group permission? Well, it's simple. We can just hit 0 for that, and then 6, right? So the middle number, it represents the group, right? So now it's read and write, easy peasy lemon squeezy, right? Or what about the other permission, right? So let's give the group a 0, and let's give the other permission a 6. Now everybody in the world can use this file, can at least read and write. So there you go, and that represents the other. Right, and then, I don't know, let's do 777. What happens when we do 777 on this file? Now everybody has all the permissions, right? Everybody has all the permissions in the world. So there you go. So that is what octal mode bits are in Bash. And as the old saying goes, like, comment, share, and subscribe. And as Cal says, like, comment, share, and subscribe.